Hello students, let us solve one more problem from CSIR exam. So in this problem, you have been given 0 and 1. They are the normalized eigenstate and we need to calculate the uncertainty delta P in the state given by this. So you have a state psi is equal to 1 upon root 2 0 plus 1, and we need to find the uncertainty in this state. Now this is normalized, and this psi you can also check, this is also normalized. 1/2 plus 1/2, 1. This is a normalized eigenstate. Now let us calculate the expectation uncertainty in delta P. So uncertainty in delta P is equal to under root P square minus expectation value of P square. So let us first calculate the expectation value of P in the state psi. So if I calculate the expectation value psi, so what will happen? Psi P psi. So this will become, so now you have 1 by root 2, and so 1 by root 2, 1 by root 2, 1 by 2 will come forward, and then you have the state 0 plus state 1, and then you want to find expectation value P state 0, state 1. 1/2 is here. And now we know how can we write P. So P in terms of ladder operator, we can write m h cut omega by 2 iota a minus a plus a minus a plus a minus is the expression for P. Now let us take it out here. So this will become iota 1/2 m h cut omega 2, and here we need to operate a dagger. So this is 0 plus 1, and then you have a minus a, and then you have 0 plus 1. Now when a dagger operates on here, okay, so 8, let us check what is coming. So this will be iota by root 2 m h cut omega by 2. So let us operate a dagger on 0 plus 1. So what will come? This will become 0, 0 will come here, 1, root 1. The formula for a dagger is what? Any state n, it gives you under root n plus 1. And so here 0, n plus 1 and n plus 1. So this become state 1, and 0 plus 1, 1. So 1 just remain 1. And a dagger will operates here, you will get state 2. But the state 2 is not useful because we have here only 0 and 1. So this is the only important term. And when a minus a operates here, what will become? This will give you 0 because a operates on n, gives you under root n minus 1. So this cannot further decrease, and this state, and a operates here, a operates on 0 plus 1. What will come? This becomes 0 and this become 1 and 0. So now what we'll have when you operating this one, we will have state 1 and minus state 0. Okay, here this state will change. So what I can write now, I can write this as a half m h cut omega by 2. We have a state 0 plus 1, and when this operates on here, you get 1 minus 0. And now 0 1, let's solve this one. 0 1 0, and this is 0 0 minus 1. Similarly, this operate here 1, and here this will be 0. So again 0. So expectation value for p is 0. So here p becomes 0. So only we need to find out now p square. So let us calculate for p square. Now let us first operate p square on this state and see what is coming. So p square is what? P square is your minus m h cut omega upon 2, and then you have a dagger minus a dagger minus a. This is your p square. And if we solve this one, this is m h cut omega will become a dagger square, and this will give you minus minus a dagger a, and then you have minus a dagger, and this is your again a square. And we know this we can write m h cut omega by 2 a dagger square a lowering operator, and here this we can write in terms of number operator. We have done many times. So this is your p square, and now let us operate p square on the state this one. So this will give you 1 by root 2. Okay, I'm operating p square on psi. This will give you 1 by root 2, and then you have a minus m h cut omega by 2. And now when a square operates on 0, okay, so this become a 1 2. 2 is we don't want 2. 2 is not, because that will be orthogonal to 0 1. And similarly this, so this is not useful. Similarly here, this will become 0, and this will also become 0. So only useful contribution will come for us with a minus commons to a bar a plus 1, and now this has to operate on psi 0 plus psi 1, and now this will come m h cut omega 2 root 2, and when this operates on here, you get number. So this become 0. This is a number, and here you operate here, you get 2, and similarly 2 1. Okay, and this will become 0 and plus 1. Okay, this operates on this one, becomes 0, because the number operator a plus a operates on n. You get n, so 0, that term will disappear. Now we can find the expectation values. So the expectation value of p square will become here. This will operate on here. So you have 1 by, so this become m h cut omega by 4, and now 0 will multiply here 0, so you get 1, and then 1 operates on here 2 plus 3, 2 plus 3, and this become 4 cancel, so you got m h cut omega, and now delta p will be simply under root of p square, that is m h cut omega. So C should be the correct answer for this question. Hope you like the solution. Thank you very much.